Sometimes I can. Sometimes I can't record, I can't save, I can't even do that. Alright, so is this an even function or an odd function? Look at your end behavior. What does your end behavior tell you? It's even. If it has matching end behavior, if they're both up or they're both down, it's even. So this isn't even. This is like x to the 4th, x to the 8th, x to the 12th, whatever, but it's an even number. So that means f sub 1 got to go, right? This is an even function, and what's that? That's odd, okay? It's an odd degree function. Alright, so this is out. That is an even degree function. Alright, let's check out this one. Is that just the even degree and odd degree? Are these two still in the running? Okay, let's go to another easy one. What about A? If A is positive, then it's going to be going up forever. If A is negative, it's down forever. So what's happening here with A? Down forever, so A is negative. That one has negative and that one has negative. That doesn't really help. That doesn't help. Okay? Let's talk about x-intercepts. This is in factored form. X-intercepts where it crosses the x-axis. Where does this cross the x-axis? Nope. -2, -1.5, -0.5, then at 2.5 and at 3. Can anybody tell me what degree f sub 2 is? How many powers of x are there? 1, 2, 3, 4, 5, 6. So it's good on degrees. It's even. It's good on degrees. I have 3 negative x-intercepts and 2 positive x-intercepts. What's happening with the graph? 3 negative x-intercepts, 2 positive x-intercepts. And one of them right here is a 2, so it's going to actually bounce instead of going through. So I think it could be f sub 2. Everything matches. Everything's good. This one is a go because it's the right degree. It's the right direction. And the x-intercepts match. Well, they match as well as we can tell, because I don't really know if that's -2, but I know that there are 3 negatives and 2 positives. Okay, let's see if it can be f sub 3. Everything we've said so far matches for f sub 3. What do we know about, it's a 4th degree, so that part's good, it's even, right? How many solutions or x-intercepts will a 4th degree have? 4. How many does this one have? 6. 1, 2, 3, 4, 5, 6. This one has 6. It should only have 4. So f sub 3 is out. It's out. The graph has too many x-intercepts. Alright, I'm going to give you a couple minutes. I want you to do the same thing with question B on your own or with your partner or whatever, just without me. You decide which one or ones would work. Okay? We'll talk about it in a couple minutes. Alright, so let's see. Can it be f sub 1? Is that a good one? Yes? Why? It's the right direction. Okay. What else? There's 3 x-intercepts. Yeah. And of the x-intercepts, let's see, 2 of them are negative, so that works out, and 1 of them is positive, so that works out. Alright, good. Could it be f sub 2? No. Why not? What? Why can't it be f sub 2? A is going the wrong direction. Yeah, it has the wrong in behavior based on that A. How about f sub 3? Nope. Why not? Too many x-intercepts. What degree is f sub 3? It's 4 degrees, and this is 3, or at least it's odd. Okay, great. Very good. All right. So we're going to complete this with all the key characteristics for quartics and quintics. Cubics has been done for you, okay? So use what they told you for cubics to complete quartics and quintics, okay? Yep. All right. Work on that. Use the other one for the model. Work on it. We'll talk about it in just a minute. So let's talk about quartics. It's x to the 4th. It's a 4th degree polynomial. All possible in behavior. Remember, on an even numbered or even degree function, the in behavior is going to match. They're both going to go up to positive infinity, or they're both going to go down to negative infinity. So as f of x, as x, as x is approaching infinity, f of x is approaching infinity, as x is approaching negative infinity, f of x is still approaching infinity. That's for when a is positive. That's for one that goes up and up. The other way, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. Okay? Possible number of x-intercepts. It could have 4. It could cross 4 times, 3 times, 2 times, 1 time, no time. Possible number of y-intercepts. 1. Possible numbers of increase and decrease. I kind of want to draw a picture for this one instead of just... It could decrease, then increase. Or it could increase, then decrease. Okay? Or it can get really crazy. Yeah. And it could decrease, increase, decrease, increase. Or the other way around. Increase, decrease, increase, decrease. Possible number of relative extrema, 3 or 1. Number of possible absolute extrema, 1. Alright, get that on your chart if you don't have it. Just to make sure that you understand, just because both of these arrows are up does not mean that this is forever increasing. Because it's read from left to right. So if you're starting on the left, it's actually decreasing until you get to here, and then it increases. This is not forever decreasing. When I read it left to right, it's increasing to here, and then it starts decreasing. Okay? Let's look at quintics. What degree are we looking at with quintics? 5, x to the 5th. Alright, end behavior for a quintic. The end behavior does not match. One's going to approach infinity and one's going to approach negative infinity. It just switches up which one's doing it, okay? If it's a positive A, as x is approaching, infinity, f of x is approaching infinity. As x is approaching negative infinity, f of x is approaching negative infinity. That's with a positive A. For the negative A, as x approaches infinity, f of x is approaching negative infinity. As x is approaching negative infinity, f of x is approaching positive infinity. Those are your end behaviors. Number of x-intercepts. Well, if it's 5th degree, it can have 5, 4, 3, 2, or 1. It can't have 0. It's going to cross. It has to cross because it has that opposite end behavior. Number of y-intercepts, it's always 1. If we cross the y-axis 2 times, we're no longer dealing with a function. If it crosses the axis 2 times, it's going to fail the vertical line test, which determines whether or not it's a function. Possible intervals of increase and decrease. I'm going to draw pictures on this again. It can be always increasing, or it can be always decreasing. It could increase, decrease, increase, or decrease, increase, decrease. Or it could like really go insane. Increase, decrease, increase, decrease, increase. This is the Loch Ness Monster. Okay? Or the other way, decrease, increase, decrease, decrease, decrease. Now there's 2 Loch Ness Monsters. And they're about
Not in school.
not in school though. Nobody wants to see that. Alright, number of possible relative extrema, 4, 2, or none. Number of possible absolute extrema, none.